All right, we're back for day three. Wow, I can't talk. Fun times. We're back for day three. We'll start off with where we left off at the end of day two, and what was done after the stream for day two. That's not on the VOD for now. So, booting the game up quickly, we roughly left day two here, where we had a consistent bounce, a jump with nothing else, and we started talking about the need to have the frog tongue animation where you're shooting to try and catch something. So right after that, after the stream, we implemented that. So now there's a tongue animation on a 2 seconds cooldown where we can actually shoot, and it's based on a cursor, which was also something that we had to add after the fact. Initially, this was a question of doing all the math around making sure that the tongue's going in the right place and along the very specific angle. So initially it was just a straight 45-degree angle. Now we actually have a cursor, and whenever we press, it goes to where the cursor was at that point, even if the cursor continues to rotate across a 90-degree angle roughly. That's pretty much where we are at the end of day two, and how we got there. Specifically, the player cursor object. This is leveraging path and path follow to the nodes in Godot. And the way this works is you actually create a path, and this can be a Bezier curve or it can be linear. So for us, there's 3 points, 2 at the exact same spot at the 1,1 coordinate, and another at 255. 255. So we go in a circular shape to the first point and come back, and this is looping. And the path follow node actually has a progress ratio that helps us to test this. So 0 to 1, or basically 0.5, is the halfway point where we've actually done the 2 motion, and then we do the 4 motion, or basically backwards all the way to 1. We also added a cursor. This is very basic. This is 2 rectangles in Inkscape with a rotation, and then the animation player is basically grabbing, let me grab the animation here, is over a half second we go through the 8 different sprites, and because this goes over a 90-degree rotation, it looks like it's continuously rotating. And even in Inkscape, there's some inconsistencies with the shape as we're rotating, probably because we're rotating from the left and not directly from the center. But overall, it makes a fairly smooth cursor considering the 15 minutes of effort it took to get it there. And now it actually looks like we've got something to aim to. So I'm just going to make sure I reverted my change to progress ratio. There we go. I'm going to save this again, and now showing it again with the cursor. Whenever I'm shooting, the tongue goes forward, back, based on wherever the cursor is at that time. And there's probably an improvement to make there to have the cursor not visible when the player is on cooldown, even if it's still potentially rotating at that point between the 2 sides of the 90-degree curve. So that was the change. And in the player, this is probably not an implementation I keep if I'm releasing this game commercially, but loosely, whenever we're getting ready to lick, so we change the actions. Now that our bounce doesn't actually need a key, we change the jump action to lick. It's still the space key, that's not going to change. And we check for inputs each frame. If we're pressing and we can actually lick, then we go and find the cursor's position on the cursor component, and we create the instance of the player tongue controller. And the way the player tongue is working in the back is there's a line that uses a red bar as a texture. Eventually this should be the sprite for the frog's tongue, or the stretching of the frog's tongue with something at the end. The area right now here, this collision shape is what's representing essentially the tip of the tongue that's going to be always at the end of the line. If I add collision shapes here to the debugger, which is going to change the colors a bit, you can actually briefly see, although it's probably a bit quick, but you can see that there's something at the end of the tongue that's going. So that area 2D node is actually going forward and then coming back, mimicking the motion of a frog sticking its tongue out, trying to catch something and then coming back. And we're going to use that eventually to trap enemies. So we're going to have to add collisions and make sure that when an enemy gets hit, it's pretty much stuck to this shape and should be coming back towards the frog. So this is done using a line 2D and an area at the end. And in the code, we're actually changing. There's still a lot that's uncommon from some of yesterday's tests, but we're changing the position of the area every frame. When we're pulling, which is the first, there's two timers. The first quarter of a second is the frog shooting its tongue out and going forward, and then the other half is coming back until we actually remove the instance of the object and delete this off of the tree. And we do this with linear interpolation, and I'm trying to get the tongue to shoot at roughly 2048 pixels. So it's going fairly far for now. That's obviously something that we can adjust when needed, but for now we're using this to test. And then the other thing here is that for the line to follow where the area is, we need to continuously every frame remove the previous end of the line and add it again, and then the line redraws and is stretched out to that latest point. This took quite a bit of math to get there, and if I go back to the cursor for a minute, and this is where it gets challenging. So the way Godot does coordinates is contrary to how people normally do coordinates, where your y-axis upwards is positive and your y-axis downwards is negative figures. Godot does the opposite. To the right it's still positive x, and to the left is still negative x, but it's inverted for the y-axis. And the reason this was challenging, or in this case specifically it's challenging, it's because our pad that goes from what normally would be 0 to 56 to 256 0 in this case is going from 0 to minus 256 all the way down to 256 0. So to make sure that this actually works and that we're shooting from the right angle, when we're setting where the target is and basically telling our tongue instance what's the target, we're actually removing 256 from the positioning to get to the right coordinate. So that's roughly where we left this yesterday. I'm going to remove collision shapes for now. Save this and go test again. And as you can see, depending on the position of the cursor, this changes where the tongue is sticking out. But now we don't see the area at the end. So I'm going to open Inkscape. Actually, I'm going to go duplicate my normal sprite file in Inkscape to make this a bit quicker. And you guys can't see it because it's on a separate screen. This should come up in a minute. There we go. So all we're going to do first is give a sprite for the frog's tongue. I've got a template in Inkscape set up to do essentially a big sprite sheet. And I don't need to use all of them, but I do want to use this top left section here, and it's going to make things a bit quicker and I can resize it accordingly. So for now, all we're going to do, we're going to grab a circle, and we're going to go roughly everywhere except for 1 pixel, or 8 pixels I should say. This looks relatively good. It does need to be perfect for now. It's a bit big here. There we go. I'm going to change my properties since I'm not going to animate this. This is really only to test what's going to be a shape that I'm going to add and make sure that this is hitting what it needs to hit for the area. So I'm going to open my testing sprites folder, paste my circle, and then on the player tongue over here I'm actually going to add a sprite. Drag my texture here, and this is obviously way bigger than it needs to be. I'm going to scale this down probably to half initially, or even lower than that. Quarter is probably going to do it. Yeah. And right now this is bigger than my capsule collision. Now this is going to be roughly the same, and as a child of the area this should move with the area itself like the collision shape did. So now if we save this and we go in the player scene and we debug, there should be a little bulge at the end there. And actually travels so quickly that the shape seems to be struggling. So now our tongue is technically complete, enough that it can be used to test sticking to enemies or anything. The other thing we're going to do right now, the launching of the game is a bit rough. We start and we're straight in the game and already kind of going for it. So we're going to create a menu. And menus in Godot are fairly simple once you understand the user interface nodes, but not necessarily intuitive at the beginning. It takes some time to get used to. So we're going to call this main menu tscene. This says absolutely nothing. The first thing we're going to do is go back to project settings. And we're going to add a pause action. This is going to be the escape button. Here we go. And this is just so we've got something to leave the game if we need. We're going to create... Gonna remove the filters for now. Going to go in containers. We're going to create a VBox container. And I want this to occupy the full rectangle. And then we're going to add 2 controls. It's going to be labels. Sorry, not vertical alignment, horizontal alignment, center. And And we're going to put this in Screaming Fonts for now. There we go. I'm also going to add a small margin here between controls. Actually, I'm not going to use the full rectangle. I want something a bit different. There we go. Going to add not a container, another label. Escape to quit. And now this looks nice, but we'll need to hook this up. If I actually go and run this as is, nothing's going to happen. So we're going to create a script. I'm just going to create a folder for me to store these. Create a new script, main menu controller. And this is going to inherit control. And we're going to attach our existing script here. I think I did something weird there. So we're going to get the ready and the process functions, specifically because we need the process function here to go and get inputs. Now this is going to give me an error until I actually implement get input. It's going to be one method. This is where we're going to go and get our inputs. I also need function start game. And function quit game. And then on the main menu here, interesting, it didn't actually grab the script I was telling it to. So put this into a different script than what I was scripting over here. So we're going to redo this here. We're going to delete main menu GD. I'll have to check the bottom of how I did this. And it is fairly quick in Godot to reattach a script, especially after you've made changes or if you actually change. So I'm actually going to make the change now. I need to be consistent in how I'm typing my scripts and naming my scripts. So over here I can go back, quick load. Right now it's going to show me every script that I think I've ever used. When you've got more objects, I'm not sure the exact logic for it. I think it shows what's been used in that context, but that's a problem I ran into with another game. So for now we're going to reattach our script. We're going to check our inputs. We're going to check if input is action pressed. Lick, which is the space button, which should start game. And if our input is the pause key or escape, This would be quit game. And now for quit game, get tree quit, and this is going to close the game. And then for start game, this is where we need to change to a specific scene here. Change scene to file, and I want this to be the main scene for now. We're eventually going to change this. And now I need to make the main menu here the main scene. And whenever I open, if I press escape, this quits the game, shuts the debugger off. And here, if I hit space, then the game starts. And it actually starts with, unfortunately, the tongue shooting out, which I should probably give it a 1 second cooldown, but this would be a weird handling of this specifically. But the space key is essentially still pressed at the time where the new scene loads, so the tongue shoots out immediately. Interesting problem to solve for not today. This also slightly goes against the theme of the jam. There is an extra challenge to try and have menus that go with only one key. It's going to be hard to make a continue or leave button with only one of the keys, so we added escape. Escape's pretty much always a standard pause key in most games. So that's pretty much it for the menu for now. And this is working. Obviously, this could be leaps and bounds better in terms of design, but we still don't have a title for the game, even if we have a general idea of what the theme is going to be. So it doesn't really make sense to noodle too much on the menu for now. So now that we've got this sorted out and this is working again, see, I really don't like how the tongue shoots out. We'll probably need a state machine at some point to make sure not to immediately check for inputs in the first second, or start this on cooldown and let the timer actually go to remove the cooldown. Because there's probably not going to be a whole lot of things directly available in the first little second and a half of loading, so it makes sense to actually start on cooldown. But there's probably a better, more elegant way to run around that, or to work around that. So now this game does not make sense without enemies. So it's going to be something we're going to be adding today. And I'm not yet entirely sure how we're going to do this. So this is going to be done on the fly. For now, we're just going to create a standard 2D scene. I'm going to call this an enemy controller. And there's a reason for this, but this is going to be something we inherit for other enemies. And if there's ever a need for different enemies, we can have varying implementations, but coming off of the base scene. So right now, there's obviously absolutely nothing here. Our enemy at a minimum should have a sprite. And to be able to give the enemy some movement, we're going to add a character body 2D. And if we go back to day 1 of the stream, the difference with the player scene, the player is a rigid body 2D, which means that the movement for rigid bodies is driven only by physics, whereas character body can be controlled by code, but you actually have to implement all of the movements, the reaction to collisions. The body does not follow physics. And then for static body 2D, which is what we're using for the platforms, this never moves. for now, whenever we have character body 2D, this is going to need a collision shape. We're not going to draw the shape just yet, or it's still complaining. Just do a circle shape for now, and you see the warning here went away. I still don't have any idea what the sprite's going to look like, so for now this is probably not going to be too relevant. The other note I want to add, because I don't actually want this character to collide with anything other than maybe other enemies, but what I really want this character to do is to trigger a signal on areas. So whenever there's a collision 2D that's entering or exiting, specifically an area, so the tip of the tongue in our case, I want this to give me a signal. So this is going to be the hurt box. And because it's an area, this is also going to need a collision shape. And until I have a sprite, this is also going to be a circle shape 2D. Now, one cool feature is the debug colors here. If I want the collision box, I can add a different color here. So I'm going to add something that's all green. And a bit more visible. And for the collision shape, the hurt, I'm going to add red. That's again a bit more visible. This one does not matter to us. If we go and set in the character 2D the collisions, I actually don't really want this to collide with anything, but this could be enemies colliding with enemies, which means enemies would push each other or bump into each other, but we don't need the enemies to be more complicated than this. And then specifically for the area here, this is going to be an enemy, and this is going to be colliding with player hitbox. Just to make sure I set this up properly, I'm going to go back to the player tongue scene, check the area again, and this is a player hitbox, and this is colliding with the enemy. So normally, once we have an enemy that actually has a sprite, this body here, when it collides with the tongue, so specifically this sprite here, we should have in the nodes the area entered signal that's going to kick in, and we're going to need to do something with that. So if I go back to, I'm actually going to make this the root node to make this a bit simpler, and to be able to inherit the character body 2D methods. And I don't want an empty node here, so I'm just going to delete this enemy controller node. So now I've got my enemy controller, I've got, let me remove this for a second, my collision shape. I'm going to have a sprite that at some point will fill. And if I remove this for a second, the other shape for the hurt box. So I'm going to save this. I'm going to attach a script, and we're also going to change where that lives. So this is going to be in scripts. Enemy controller.gd. Just looking at something on the side before I get back. Okay. So we want this class name to mirror the script name, so this is going to be enemy controller. Then we know that to function, for the enemy to be able to work and to get what we need an area to the hurt box. Then we also need, actually I won't do anything with the sprite for now, but once we're going to do animation, we're going to need the sprites. So I'm going to eventually create a connect signals function, and there's a purpose for that. I'm not going to do anything with process for now. I'm going to go and create my connect signals function. And before I call this, I'm going to validate that my herd box actually exists. And this is because there's no try and catch in Godot, so asserts are the next best thing. And what this does here, I'm just gonna write the description here. Needs an area 2D herd box control. Okay, what this does, an assertion for non-devs out there, you're validating that this condition you set is always going to be true. Otherwise, you actually throw an error and you display the error message. So our assumption here is that this will always exist. This will always exist, this herd box, under the enemy controller at this exact location. There's more optimal ways to do this, but specifically we need to make sure that the control exists or the entire logic of the class falls apart. And the reason why I'm insistent on doing this first and foremost is I'm going to connect my signals, and the first signal I'm going to leverage is area entered. So we're going to connect to that signal on herd box area entered. Now the code might whine a bit because it doesn't know that function yet. So we're going to create this here, area entered. This is always an area 2D variable. We're also going to make this a void, and same thing for connect signals. So signals in Godot are the equivalent of events in just about every other programming language. C# still does events, Godot does signals. The only constraint with signals is that unless you actually run a signals hub or an event hub as an autoload class, your signals are some things you always need to hook on each instance, which is where the event hub, if you want to throw something for any other object to potentially consume, makes sense. We don't have a need for a signals hub right now, but as we flesh out the scope of the game, there's probably going to be a reason to add this, and this will be something we'll be showing once we need one and we add this. Other thing I'm going to do is a disconnect signal function. And this is specifically to release any signals when we release the object or when we queue and free the object. So once the enemy dies, we want to make sure to unhook any connections we have, specifically in the event hub. It's more important than on this specifically, when this object is going to disappear along with the enemy controller when we get caught. But when using an event hub, it's going to be really important that when disposing of the object, we remove our signals. So for this, I'm going to do 3 exiting. So when this object is leaving the tree, we're going to add a signal or a method signal handler called onTreeExiting, from which we're going to call disconnect signals. And this is probably suboptimal on this, but it's a habit I've taken to make sure that I'm releasing all signals because I'm using an event hub. Elsewhere, this probably helps the garbage collection process when there's a static reference that's holding multiple signals, if you're not disconnecting it, I wouldn't be surprised if we're getting errors there. The other thing I'm going to do, some code hygiene here. Thankfully, Godot added the region annotation in 4.2. This allows us to group code under a region and end region tag. As someone who's worked with C# before I worked with Godot, this was something that I was really, really looking forward to having. They added it in 4.2, and that's when I immediately changed the engine version to make sure that I could benefit from this. If I structure this like most of my code normally, it's going to be override functions. Okay, so for now we don't have much here. All we have is that whenever there's an area that enters this, we want to keep a reference to the area, but right now there's no implementation here. All this does is when we start the instance of the enemy controller, we connect the signals and we disconnect them when the object gets cleaned and we no longer need the reference. So whenever we're going to call Q3 on the enemy, this is going to get called, and then we're going to disconnect our signals to make sure we're not leaving any references to signals. Again, probably overkill in this case, but as soon as we use an event hub, it's going to be good for the event hub not to have calls to things that don't exist anymore. So going back to the enemy, this still does nothing. We're going to need a sprite. So I'm going to boot Inkscape again. I'm going to have the testing sprite here, again, from my predetermined sprite sheet. So what we have is an 8x12 grid. This gives us the room to do however as many sprites we need in Inkscape, because unlike Asprite for pixel art, Asprite actually supports sprite by sprite. This is a bit of a hack to be able to do this in Inkscape, which does not necessarily have that function. So all I'm going to do for now, and this is going to be very simplistic, it's probably not even going to look like a fly, but I'm going to have a body. I want this to be a bit darker. I'm going to change the stroke paint. Good, then I'm going to add another shape. This is going to be a wing. This is going to probably look closer to Navi the fairy than an actual fly. Just going to go back to my controller here. So, right wing, body. I'm going to duplicate the right wing, make this into a left wing, and I should be able to, yeah, flip horizontally. Then we're going to move these. This really looks like antennas more than... Yeah, this does not look great. If I go to my wings, I want these to be roughly transparent, so I do want the stroke. I do need this to be Not sure why I took sky blue, but for now that's gonna have to do. I still want my stroke to be dark. And same thing here. So what are the colors I use for this one? 200, 180. Gonna create another wing here. There are little flutters. I'm also gonna do the same thing I did for the first one. Duplicate the second right wing, bring it under the body, and flip it 90 degrees before I move it to be. There we go. Doesn't really look like a fly, but does look like something that could fly for now. Again, the goal is not to actually have the completed art here, but really something to test with. I'm gonna go and grab my file and add that to the sampling folder that I'm using. There we go. And I anticipate this being an animation, which is why I've left the rest of the content in, all the empty sprites. So for now, in the animation, this really simplifies sprite sheet cutting in Godot, but within a second, I already have the object that I'm looking for. Just specifying how much horizontal frames there are on the sheet and vertical frames. And this helps us actually export an SVG. And this is way too big initially, but as soon as we have a sprite sheet, this is going to enable us to have the sprite sheet, cut it, and then we can go to the animation, which is what we've done for the cursor here. The cursor is just 8 frames horizontally, and we cut this and we go and create the animation. So no animation for now for the fly. We're going to go back to our sprite 2D. And right now my collision shapes is nowhere near as big as my box here. We're going to try and make that consistent, but I did kind of rush a circle. And I do want my hurt box to be bigger than my than my collision box, but just in case. No, I want this here. There we go. I actually want this collision shape to be... I keep accidentally selecting my hurt box. There we go. So I want this to be a bit smaller. If you've played games like Vampire Survivor, this is where, to an extent, you can see that enemies have a slightly smaller collision box so that they can collide with themselves, but their hitboxes where the player takes damage is actually bigger. So I'm just adjusting my sprite here to be roughly centered to 0, 0. I'm going to add my collision box again and center this with this guy here. So I now have a controller. There's no movement. What I'm going to do to test my collision is add an instance of my enemy here. I'm going to give myself a good shot at catching it by having it right here. And what I want to do is debug that I'm actually seeing the right mask when I collide. So collision layer value, this should be layer helper. I forget what I name my method here. Layer names, or my array, layer names. And just to make sure I don't have a typo, we're gonna go and check the collision layer names. There we go, enemies with a capital E. And this needs to be a string. Why did it not find layer names? What is it complaining about? Oh, I know. So this should be my autoload class. There we go. And now I got breakpoints to know, am I actually hitting the right collision and having the right area entered? Or am I actually not getting anything if I manage to hit? So I'm going to do a test. I'm too short. Okay, we're going to go back to the main scene. This is higher than I expected somehow. We're going to put this here, give ourselves a maximal chance to hit it. Save this and go after it again. There we go. So we did hit an area, and in the collision layer value, we're not getting enemies. Why is that? What is the area we're hitting? Yeah, that makes sense. I got the wrong layer. So this is player hitbox. I am the enemy, not colliding with myself in that case. That makes sense. Player hitbox, there shouldn't be a typo. Now I'm expecting that this is actually going to work. And I missed my opportunity. Let's redo this. And let's make sure I'm right under it when I'm about to hit. There we go. Now I'm hitting the first pass that's indented under the hit. So now I can actually add my logic here. So my logic, we're going to start with comments first. So we would set some variable somehow that basically says that the enemy was caught. In the longer term project, this is probably where a finite state machine is going to help, because the enemy is going to wander around and move until they actually get caught, which is going to be the entry state. Whenever we get hit here, we enter the caught state, and then we move to the next steps. So we need to set the enemy state to caught, and we need the enemy to follow the tip of the tongue, or to stay stuck on the tongue, essentially. So we need the enemy controller to stay stuck to the frog tongue. And we need to change the process method to move the enemy every frame. And on the player, there's also going to be something to do, but for now, that's the first thing to do with the enemy. And whenever we actually get touched, so for now, we're going to use a caught variable. This is probably not great, but bool, and this is going to be false by default. So the first thing would be is caught equals true. I also forgot to add my signature here earlier, so we're going to fix that. Now we need the enemy controller to stay stuck. So for this to work, this is actually going to be done in the process method. And we're going to code this independently, but we do need to keep an area reference. This is a super bad variable name, but we're going to call this player hitbox area and try to keep this simple. This is where we would set player area to this area 2D here and keep a reference. And we can probably remove the pass here. Going to create ourselves a region to actually go and add some code here that's not related to the signals, and move with player object, or with player area. This is going to be a void method that doesn't return anything. So if this is caught, we're going to move with, how do I call this? Move with player area. And if we're doing something with the movement or calculating the movement ourselves, we probably need the delta here. But for now, that's probably overkill. But just as a good practice, in case that's needed, we could pass the delta as the float and call. And if there's any calculations that we do ourselves here, we could do that, but we're not going to need this. And then the other function I'm going to add is to actually move on our own. So if we're not caught, just making sure I'm not overriding anything that exists. No, I'm good. And because this would not have inputs, we'd process move. And in this case, we likely need to pass the delta because we're going to be moving on our own and not following an area. And there we go. And now to move with this player area, we're going to change a position. Actually, so position, now I'm not sure if this is going to work. I have a feeling this is going to fail because this should probably be following actually the global position. I'm going to try this and see if this works. So position is a relative variable based on where you are relative to other nodes in the tree, and global position is the actual XY coordinate based on the full scene. So if I go to main scene for a second, the axis here, or the measures you see at the top, like the axis gradients, are the global position. But then if you're looking at the player, for example, so its position on this scene is actually the global position. But then when you go into the player scene, the position of controls, or in this case the offset for the camera, but the sprite 2D, for example, this position is 0, 0. This is all relative to your player node here. So when you're saving prefabricated objects or scenes, you're actually speaking in, like for the position, you're speaking relative to the position of the main node. So in this case, my cursor actually has a small offset, so my position is this 32 here, and we're going up all the way to minus 288. So 256 pixels plus an extra 32, because I expect that if my frog is 64 by 64 pixels, which is what I've roughly tried to mimic here, right? Like this is not, it's a bit different than that. This is bigger, but you'd want a 32 by 32 offset. If I can get my zooming and scrolling right, there we go. So this would be actually closer to 64 by 64, and this is my 32 offset. I think this is about 55 each side, so 110 pixels by 110. But I did put in an offset right now of roughly that 32 pixels, and because the way I've built my player cursor, the cursor is on the top left here, which is where I'm adding an extra 256 pixels. So going back to the main scene, the enemy, now on my controller, if I go back to scripts, we're going to see what this gives us when we actually get hooked. And we actually start moving every single frame once we're caught. And we're also going to make sure that this actually executes like we intended to. Okay, so our caught variable is going to get told to switch to true. We're actually going to assign the player hitbox area, and then it gets us back to the inputs. And then on the first frame processing, once we're caught, which this is working as intended, we're going to change our global position based on the player's hitbox. So the player's hitbox is 173 and minus 281. And what is our current position? 357 by 698. I'm not sure that makes sense as the global position. Because 698 should be down. We are actually under 0, so that may make sense. Maybe. I'm going to remove this and we're going to see how it behaves. This is interesting. So it looks, staring at the screen, like this is working, but on the frame where the tongue disposes of itself, this seems to happen before the insect has actually gone back. So before, just because it's based on a timer, before this is fully returned. And this is why it's giving me a runtime error now. So let's stop this for a second. I do want to see how the interaction works outside of this, but should be something for me to check that, yeah, it's queued for deletion. And again, there's going to be another way to handle this, and we probably actually need to go a bit longer than expected on the line shoot. But let's see how this works with this. I should have removed that boy. Yeah, okay. So let's do it again without the breakpoints, and I can explain what's going on here. Actually, no, this is working exactly like I'm intending it to. If I'm not stopping during the debug where this runs for, okay, I know what this is. Yeah. So we're gonna go to the player scene. So what's happening right now, sorry, the player tongue scene. What's happening right now is these timers are processing even when the game is paused. And I need to remember exactly how to avoid possible stops when the scene tree is paused. And inherit by default is possible, so this should be working. Essentially, my timer runs out and starts disposing of an object during debug, and that causes my object to not stay, but it's working correctly at execution. So we don't want to continue processing always, so possible probably is the right mode here, and this seems to be something that only happens when we're debugging. Yeah. Because the next step here is if we go back to the player, I do want to add an area on the player. And again, we'll have to see how this works once we add sprites. But there's probably going to be a frog mouth sprite somewhere for which we want an area. And the reason we want an area that's going to be set to the enemy specifically. So this is going to be frog mouth area. We're going to add for now the usual collision shape. We're going to make this a circle. And we're going to move this here and expand. So what I want to see happen is once that shape comes, or once a fly enemy, or my weird version of, I guess, Tattle the fairy, whichever's the darker one in Majora's Mask. When I hook and it comes back and it collides with here, we're going to need some logic to remove the enemy from the game and do something with that on the frog side. So specifically, once you eat an enemy, there should be a bonus in some way, shape, or form. You either get energy back, you get some currency, you get speed, you get, if for some reason we have bad enemies down the road, you get a debuff, but something needs to happen. So for this to work, I'm going to do collision shape 2D just to distinguish from the various collision shapes I'll have. And here I'm going to do some code cleanup. So override functions just like I did on the enemy, and region. And I've got some signals here. So we'll do a signals connect, signals functions. So similar to how I do this on the enemy, and this is something that in the code I'm usually consistent across objects, so that I know that when I'm stepping into an object and there's signals, I expect to find these two methods to do all of my handling unless there's something that needs to happen at runtime and we're creating a timer on the fly, similar to here with the body entered. So this is on collisions on terrain. We wait a second before we actually go in and jump again. A million better ways to do this, and this is where eventually there's probably going to be something in the connect signals method here. For now, I'm going to copy these two calls, or these two lines of code, and I'm going to comment these and change this for connect signals. And the other line I'll add 3 exiting connect. And the method doesn't exist yet, so I'm going to do this here. I'm going to copy all the signals that I'm connecting. I'm going to change this to disconnect. And fix a typo here. This should be working. And then to be consistent, I want these to be in the region with the signals methods. And what's the other one? Lake timer expired. There we go. I don't need pass here. I don't need pass here either. And I definitely don't need this anymore. Okay, we're going to start this again, and I'm going to make sure I didn't break anything. It looks like all of this still functions as expected. There we go. So my events are working as expected. I do have a lick cooldown, and my jump is working on collisions. So this is working as intended. I can remove these two lines here. I'm already doing assertions here that my cursor exists. The other thing I'm going to want now is going to be my frog mouth area. It's going to be an area 2D. And there's going to be better ways to do this with composition. If you ever have different kind of players, this is always going to be a frog, but in a game where you have different players, potentially with different weapons that behave slightly differently, there's parts of this that could be work differently through composition. Maybe the cursor is going to be different. Maybe the scene that you're using for the tongue is going to be different, and instead of being a preloaded variable here, would be an export variable so that it shows up on the inspector, which is what we've done with the cursor. Probably overkill in that case, but it works. But with composition, whenever you're going to start using inheritance or creating inherited scenes from this is where composition is going to allow you to just set your controls. And in the implemented scene implementation, you basically add the implementations that you need of these specific components to be able to leverage them, rather than traditional inheritance, and not in game dev but in object oriented, where you'd edit the properties of or basically do the changes on the child class. Composition's a preferable pattern for the inspector in managing the nodes, because then you leave the implementation up to the component. And you're just assuming that a component in particular can fit there as long as it follows the base class of that component. All right, going back to this, I will need to add, and the other reason we did this is, first, we're going to assert that our frog area exists, or frog mouth area exists. So we assume that this is never null, and this condition is always going to be true. But if it isn't, we're going to leave an error message. And in my assertions, I usually specify what's the type that's needed. I didn't do it here. Actually, yeah, it is player cursor controller, so that makes sense. This is more specific for which variable is giving me the issue. I'm gonna add the region here. And now here, and the reason I did all of this is we're going to add on frog mouth area entered with an area 2D parameter, similar to what we did on the enemy side. For now, I'm not going to put any logic here. I'm going to put the method signature. I'm going to go and add my connection here. So on area entered, connect. And I'm going to copy paste this line and delete pass while I'm at it, and go and disconnect once I'm releasing. Just remove some indents that don't make sense. Okay, so now I should hit this, so that we do need to validate the collisions here. So this is the player. This should be colliding with an enemy. So do if area get collision layer value, layer helper autoload, this is enemies. And we're going to do something here when this happens. So specifically on the back and forth motion, when the frog shoots its tongue out, catches a bug, and brings it back, this is going to be called, and we need to do something with this. So let's see if this works, or if we run into a hiccup here. There we go. So we've collided with the enemy. We can do something. There's probably a better way to do this, because with the area, we're going to need to be able to get back to the parent. So this is where we'll probably change the hitbox component, or the hurtbox component, the area, from just an area to a hurtbox class, and validate that this is the class, and toss a signal back to the parent saying, I got caught, and now I'm in the mouth to know to dispose of itself. There's probably a quick and dirty way to do this, but no, we probably have to convert this to a component right away. So I want to save this branch as a scene. We're going to go into the enemy. So scripts, or sorry, scenes, enemy. This is going to be hurtbox component. So when the enemy is getting hit specifically. And I'm going to open this up, and we're going to make another change. And this is where components come in handy, but we're going to add a script here. This will inherit area 2D. Hurtbox component for consistency. This should be in scripts. There we go. We're going to give this a class name as always, hurtbox component. The first thing we're going to do, and export a variable that's going to be this is going to be collision object 2D, and I want to see the documentation on this to make sure, but This might be overkill. We might need to do shape. And if I check on another game I did, oh, we actually don't add it. It's even better. So we're going to go back to scripting, and we're going to close the documentation. So the way I've done this elsewhere, I'm actually going to remove this. We don't actually need to do anything on the collision. All we want here this is going to be let's be dramatic, eaten by player. So we're going to create a signal, and this is where this becomes important. So we're going to rename this HerdBox component, and we're leaving the implementation of the collision box up to each sprite individually. So I'm going to remove this for now, and now instead of doing this way, we're going to do export our HerdBox component. And we're going to assert, I can replicate this one, but I'm going to keep this for testing, and we're going to assert that, I'm just going to call it HerdBox for now, and rename this for consistency later. We need this to exist on the enemy controller and actually be set. So we're going to instantiate here, HerdBox component. So now this exists. We do need to give it a collision shape, and this is where not having a variable that forces either the specific polygon type or shape type means that we leave the implementation of the collision boxes up to the enemy. So in this case, I'm going to go back to the circle shape and expand this bad boy. There we go. Roughly to where we were at. Let's try one last. There we go. So now my warning around the HerdBox component disappears. This is going to fail when I launch for now because I've not assigned this. I didn't realize I was also still debugging. So this is going to fail because now the enemy actually needs the HerdBox to function. So go in the enemy controller. We're going to set this, and there we go. That's a quick demo of the composition pattern. And now this should work exactly as expected. I really need to fix that tongue shoot on start. There we go. And now something happens, and we need to do something with this. So we're going to assume that our area here, because it's coming from the enemy, actually is the HerdBox. We're going to cast it, and this should work. And then we're going to emit the signal that this got eaten by the player. Probably should be doing this on the enemy side, but on the enemy controller specifically, so if I go back to my script, the other thing I want to do in connect signals now is on the HerdBox, I want to connect to the eaten by player. I'm getting warnings or errors because my method doesn't yet exist. player this void, and we're going to queue the enemy for deletion. I really don't need these breakpoints anymore. So now we know that we emit the signal, so our enemies should be deleted at that point. There we go. So now the enemy gets deleted. We still need to do something with this, right? Like we still need so this is something we're still sorting out, but what does each enemy provide the frog when eaten? Given that we're doing this for a game jam, there's probably not a whole ton of logic. Is the enemy going to give HP back to the frog if the frog's losing energy as it's going along? Is it going to change the speed of the frog's bounce? So specifically the jump. Are we going to have something that influences our base velocity vector by adding to it? And we'd probably be adding to this before we apply each impulse. Or is there something else that we're doing? So that's something we'll need to figure out at that point. But for now, the enemy disappears once it's eaten. But there is a need to add whatever we got from that specific enemy, which should be something that's a property on the enemy, or depending on the type of the enemy, whether through an enumeration, something we check with the scene, or whatever, how we implement this, like whichever way we implement this, we're going to try to find a way to get the stats that we need out of the enemy. Maybe this is something in a level controller, maybe this is enemy by enemy. We'll figure this out as we kind of refine the scope of the game. Now I'm just going to clean up a little bit. This looks better. These are other functions, so I'm going to do the region here. So another thing I mentioned a minute ago is the frog as part of the game, and to make the game finite and something that runs over a few minutes, should have a health component in some way, shape, or form that checks how many HP the frog has, and whether it's HP, energy, or anything, but some degree of bar that gets emptied every time the frog jumps by a set amount. So if we're going to do this, if I was going to do this the quick and dirty way, so base health, or really max health, let's start with that. So this is going to be 100 turn health, and make this a floating number just in case there's decimals, and this will also be how much do we lose per jump. So every time I jump, I'm going to remove 5 health from the current health, and I need to do something if this happens when I'm at 0. There could also be a lick cost. Let's throw added complexity for our sake here. Something like this. So every jump we're going to do current health jump health cost, and every lick where we actually lick, so not at the beginning of the method, at the end, current health, lick health cost, and at the beginning, when I initialize this, my current health is going to be equal to my max health. So this should start as 100 and just gradually start going down. I don't know why I started without having a debug variable, but I'm gonna have one here, I'm gonna have one here. So my current health here, 100, my cost is 2, 98, and then next time during the jump, I should be at 98 here, and that's gonna take me to 93. There we go. Now, I'm going to remove these. We're going to have a death function or a lose function when the health reaches 0. We're going to have a health change function to do this a bit more smoothly. Actually, we're going to do minus equals the value. So we're keeping our values in positive. There's an argument to be made that we're doing a negative cost, but instead of doing that, here we're going to do changed. Actually, no, I need to do plus equals because, and switch these two negatives. Because once we're actually going to catch a bug, we're going to add health eventually. So there should be health change. For now, we're going to do 5, for example. So bug health gain 5. I'm going to change this so it's not hard-coded. And the reason we have a method now is that there's only one implementation where we change to health, and if current health lesser than 0, lesser or equal to 0, die. There's also potentially here change health or emit a change health signal, and this is going to be useful when we have a health bar on screen. And what do we do when health reaches 0? We're probably going to need a game over menu return to main menu or restart. So there's going to be added steps to do here. We're probably not going to get to the death animation in this specifically, although I'll try. Maybe I'll get to it this stream. And I'm going to put a breakpoint on the health change for now. So that's the initial lick, minus 2, so it's going to be 98. Yeah. The first jump, 93. I don't know why the tongue went out there, because I didn't press space. It's going on click for some reason, which is a bit strange. So for now I'm going to remove this and track it on the bug health gain instead. Stop this, because I really don't know why it's looking at the action press on click. That was strange. There we go. So bug health gain should be 5. Current health 81. I licked twice. I jumped 3 times. That makes sense. That's good. And now we're back at 86. And if I wanted to test the dead, I would just mash space. But the truth is I probably don't have enough runway to do this. So now we're going to go and change this to 50. And I'm not going to do anything with this yet. I just want to make sure that this actually gets triggered. So I'm going to voluntarily miss the health gain. And just keep mashing space until I'm actually out of health. There we go. So at some point, I reach 0 in health, -4 in this case, and the player dies. It's game over at that point. We could do something where if it's in the jump, we trigger something that, like, if you don't catch something before you land, you die, but that's overkill. But it would be something that's kind of cool, like a last chance thing to implement. So I'm going to remove the breakpoints here. This is working. I'm going to set this back to 100. And I'm going to start looking to implement a HUD and have the health component with the progress bar. So I'm going to go to menus. I'm going to create a scene. This is going to be a user interface. This is going to be player HUD. I'm going to want this to be an overlay. I'm going to add a margin container first. This is going to be the full width of the screen, but so I do want 10 pixels of margin between everything. Here we're going to add child node. And this is going to be a progress bar. Progress bar, there we go. So we're going to show the percentage for now. We're going to leave the values. This is fairly close. And the theme overrides. Again, super overkill for now, but we're going to add a script to our HUD, making it consistent with everything else. Scripts, menus, player HUD. This is going to be the health bar. For now, it's just a standard progress bar. We'll probably want to use texture down the road and do something funny with the image. With maybe it's something like in some games with energy, could be a battery going down. This could be something with the frog and just the tongue gradually retracting. So we're gonna add the progress bar, and we're actually gonna give this a unique name. Health bar, and I want to access his unique name. So this is going to be my health bar. This is going to find it. Beautiful. Not sure if we're going to need to do anything on ready or on process yet. I'm just going to keep these in case I need them. And the functions I want for sure is going to be to fill the progress bar and empty the progress bar. So health changed, new value, float. Health bar value, new value. This is probably a dirty way to do it, but this should give us what I need in terms of, or give me what I need in terms of this for now. And I need something to set this up as well. So function setup health. So this is going to be max value. So we're going to set up the health bar, and this is going to be on the player to actually initialize the HUD, set up the health bar, make sure we've got whatever the HP is and whatever is the current value. And we're using a percentage for now, but eventually we could do something with a text box and do a custom health bar component. This is probably the right level of involvement for now. And I'll probably have something to tweak on the Z index to make sure it shows up in the right spot with the player. So I'm going to go with the player scene, and I want to grab my HUD and instantiate here. And I want this over the player, but right now it's yeah, so we're gonna have to change something here. And I forget where I've coded this, if I did this on the object by default. Yeah. See, so now it shows up. I'm just not sure why it's not taking the entire screen. Oh, it's if I add it to the player. That's I could give it my minimum size. And make sure that it's anchored on the top left. That's probably wrong. Let's see how this looks. It's gonna need an offset if I'm using the full rectangle, so I need this to be in line roughly with the camera. And my camera is offset, which means my HUD is going to be offset as well. Let's see how this looks now. No, it's jumping with the player. That's unfortunately normal. I'll have to figure out a way to fix this. The player HUD instead probably should go in the main scene. Or it could actually go in the camera. Now it's changing width. So I'll have to sort this out. It's going to be a bug to play with and handle differently. The camera's not moving, and because it's not moving, this works great for the camera, but we're going to need to make sure that child components behave the same, which is not the case with the user interface. Okay, let's not dwell on that. Let's go and implement the health bar for now. I'm too focused on this. I'm going to want to fix this at some point. So, okay, I got this here. Then I'm going to go to my player scene. We're going to make sure that I actually have a player HUD. And we're going to assert that I have this as well. That's the class itself. So this is where we would use the HUD and set up the health bar with the max health. And then every time there is a health change, so in the health change method, we're going to grab our HUD here, health changed, and we're going to set this to current health. And if this is lesser than 0, we don't need to go beyond the minimal value, although progress bar should handle that on its own. And we'll make sure that the HUD progress bar actually does. So this is not going to fix the health bar jumping, and this is going to assert, yeah. I need to go and set my component here. And now this changes every time. There we go. Now we got a health bar. It jumps, we'll need to fix that, but we got a health bar. So now we have an enemy, we have a health bar, and this is starting to shape up and look like a game. We're almost there. We'll need to add graphics, we'll need to add a bit more with the bug specifically, but this is much better than what we initially had Friday night. This team is starting to come. We're working on the art separately, which is why this is shapes for now. But this is going to be additions over the next few days. We're going to start adding some of the art for this to make sense, so that I'm catching something other than poor Navi the Fairy or the Majora's Mask equivalent getting caught again and again and again. And we'll add a bit more theming elements so that this is actually a small, complete game by the time next Sunday rolls around and the submissions for this game jam are due. That's where we'll end the stream for today. Follow if you enjoyed the stream.